Welcome to Year 1 Statistics Chapter 5 Prep Practice Test on Probability. So question 1 asks, if events A and B are independent, then what can we tell about probability of A intersect B? That means A and B. Well, the condition for independence that's most commonly needed in an exam is that two events are independent if and only if the probability of A and B is the probability of A multiplied by the probability of B. So that's all you need to write there. There are other conditions, but that's the one that involves probability of A and B. In this Venn diagram, shade in the probability of A or B. When shading in A or B, you want to shade in the whole of A and the whole of B. The fact that A and B is shaded twice doesn't matter. So out of the 4 regions, you need to shade 3 of them. 10 students are surveyed. 3 combine walking and use a bus to get to college. So here we are. Walk and use a bus. 5 walk all or part of the way. So walking all the way or part of the way and the other part by bus. That's 5. 6 use a bus. W is the event walk some or all of the way, and B is the event use a bus to get to college. So the way to start this is that 3 combine walking and using a bus. If 5 walk and this is 3, then this must be 2. If 6 use a bus and 3 use a bus and walk, then 3 must use a bus and not walk. And because there are 10 students in total, the sum of all these 4 regions has to equal 10. So if the sum of the union of W or B is 8, then the region outside W or B is W and B is 2. One student is chosen at random from the 10 surveyed. Find the probability of W or not B. So that means that we are in W plus outside B. So that's the OR. So we'll count everything that's inside W and we'll count everything that's outside B. So inside W, there are 2 and 3. Outside B, there are 2 and 2. We don't want to double count this 2, so it's just 2 plus 3 plus 2. So that's 7 out of 10, 0.7. Are W and B mutually exclusive? To be mutually exclusive, the probability of W and B would have to be 0, but it's actually 3/10. So because W and B is not empty, the probability of W and B is non-zero, then they are not mutually exclusive. You can be both W and B. Okay, from Venn diagrams onto tree diagrams. A bag contains 3 red counters and 5 blue counters. A counter is chosen at random, not replaced, and a second counter is drawn at random. So that means that we have fewer counters left the second time that we draw a counter. Complete the tree diagram to show the outcomes of this experiment. So if there are 5 red counters and 5 blue counters and 3 red counters, the probability of a blue is 5/8, so the probability of a red is 3/8. If the first blue counter is drawn, then there are no longer 5 blue counters, there are only 4, and there are only 7 counters in total. So now the probability of the second counter being blue is 4/7. And the probability of getting a blue first counter and a blue second counter will be 5/8 times 4/7, which is 20/56. And we can do the same thing for each of the other roots to complete these probabilities. So as we go down the tree diagram, we multiply, and then each of these roots is given by the probabilities here on the right, and these probabilities have to add up to 1. So find the probability that both counters are the same color. They could both be blue, which is 20/56. That's 4/7 times 5/8, plus both could be red, which is 3/8 times 2/7, which is 6/56. And if we add them together, we get 26/56 or 13/28. Find the probability the second counter is red. Well, the second counter could be red, the first one being blue and the second one being red, which is 5/8 times 3/7, plus the first counter could be red and the second one could be blue. Plus if the second counter is red, it has to be the first one is red and the second one's red. So it's 3/8 times 2/7, which is 6/56. And if we add those together, we get 21/56, which is 3/8. Show the event the first counter is red and the event the second counter is red are not independent. Well, the probability the first counter is red and the second counter is red is 3/8 times 2/7, which is 656 or 3/8. The probability the first one is red, we know is 3/8, and the probability the second one is red, we worked out from C, is 3/8. If we multiply those together, we get 9/64, and that's not the same as 3/28. So these two events are not independent, they are dependent. So knowing that one of them occurs changes the probability of the other. So for example, if we know that the first one is red, that changes the probability that the second one being red either increases or decreases it, because as we can see, when we multiply these two, we don't get the same as the AND probability. We'll see next year when we come on to conditional probability, there's another way of stating independence, but for the moment, this is probably the best one to learn. That's it, apart from saying that for probability, it's important that you understand how to use the symbols for events and or not. The symbols for not are variously a line over an event or a dash afterwards. You need to be able to work with Venn diagrams, and you need to be able to work with tree diagrams. We've done many of these at GCSE, but make sure you're confident with all of these. That's it.